Alright? Super cool. So I just rewrote this. And all math is really just keeping things where they are, rewriting pieces of it. That's all math really is at one level. Rewrite that in the way it is. What's the cube root of 8 also known as? 2. And what's 2 squared? 4. Let me see if some of you guys understand this. Break 8 up into 3 parts. What would it be? 2, 2, 2. Like we're doing a cube, right? Like we're doing a difference of cubes or something? 2, 2, 2. So this says 8 to the 2/3. It says take 2 of the 3 pieces of 8. So what's 2 2s? 4. If you don't quite get that, it's okay.
That was awesome.
Thanks, man. You kind of get that? I mean, that's, I don't know if you really get that or if you just okay.
So what you're saying,
You don't have to look at it that way if you don't quite understand what I'm saying, because you can always do this work here.
okay.
But it's really interesting. 8 to the 3/3 is a whole freaking 8, because it's all 3 parts of 8. 8 to the 2/3 is 2/3 of 8 multiplicatively.
Okay.
8 is 2 times 2 times 2, so 2/3 would be 2 times 2, 4.
Okay.
If you don't quite get that, or if the numbers get really ugly, just do this. You'll be fine.
I see. Okay, Jeff. Okay, what you're saying now? Okay, if you write the 8, you put 2, 2, 2, 2 up there, right?
Yes, you put 2, 2, 2.
Right.
And this says take 2 of those 3.
Yeah, and that's going to give you.
That's
going to give 4.
And that matches up. So that's one way to look at this. If you don't like this, this is more a conceptual way. This is the get your teeth into it, nuts and bolts way. Right? So this is a good way to do it at first when you're just getting used to this stuff. So what about this? Let's do this one together. Because we're going to make one that's ugly. Let's do 125 to the negative 2/3 power. Knowing me,
25.
what do you think the first thing I'm going to say to do is?
5. It's 25.
What do you have to do? What's the power tell you to do? It tells you to
Take
flip it. Flip what? Be careful now.
flip the numbers. It'd be
Flip
3 over
what
2.
numbers?
It'd be 3 over 2.
No. Is 2/3 being raised to a negative power?
No.
No, 2/3 is a negative number. What's being raised to a negative power?
125.
That's what gets flipped in, right?
It's 1 over 25.
What's the negative power acting on? Don't make this 3 halves, because then you can't even do it. That would suck. You can't break 125 into 2 pieces. Flip this.
Oh, okay.
What root am I taking?
3.
And notice this. Here's something really cool about these. What's on the bottom of
5
plants?
times 5.
What's on the bottom of plants?
Roots.
Roots. So on the bottom is the root.
Yeah.
And the top is powerful, so that's the power.
Yeah.
So on the bottom is the root, the top is the power, because the root's on the bottom of plants. All my botanists out there, shut up about the plants that have their roots on the top. Don't tell me that crap. Most plants have roots on the bottom. Cube root, right?
Yeah.
Of 125 squared. And what's the cube root of 125? This is what you guys
Five.
good, right? That's one we should know from the cubes thing we did, right? 5 squared, 25. Same thing as before. 125 is 5, 5, 5. 2/3 of that would be 5 times 5 is 25. But it said negative power, flip it, 1/25.
Because it's negative, you have to put the bracket.
Because it's negative power. Okay. How about 32 to the negative 3/5 power?
Easy.
So would you have to
So it's the same thing as before, right?
Yes. You have to flip
Okay.
that one.
So 1 over 32.
3/5.
Now what root am I taking here now?
5. 5.
Fifth root of 32 to the...
So that
Now don't freak out. Don't freak out. What do you think 32 cut into 5 pieces would be?
2.
2. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. You can always, if you're not sure here, you can always just start breaking 32 up. You'll notice quickly that it's got to be 2. There's 5 2's that make it up. So the fifth root of 32 is 2.
2.
And 2 cubed is 8. Notice another way, you kind of, like, when I say square root of 49, you guys don't even really think about it. What's square root of 49? But it's because of the fact that the root tells me how many things does it take to make this? How many of, what does it take 5 of to make this is really the question it's asking. And if I multiply 2 5 times, I get 32. That's why the answer is 2. Because the question this asks is what does it take this many of to multiply to be this? That's the question that a root asks. And again, math is all about shorthand. I don't want to write that damn question out for every. Let me just say this means that question. It's a lot quicker to write now.
It means the bottom is the root and the up is the power.
I love it. Roots on the bottom, like they are on plants. Powers are powerful, so they go up top. Just a way to remember, right? Okay. Whew. So rewrite this in radical form.
Radical.
Radical means roots, yeah. Radicals are roots. Yeah. You obviously can't work it out, so don't try to get an answer. What root am I taking?
Root 7.
Yeah, it's the 7th root, right?
Yeah.
You can either write this, or you can actually write this if you want to. As long as the square is in there somewhere, on the outside or the inside, I don't care. Because this and this, don't they make the same thing anyway? If you have the squares on the outside or the squares or on the inside, it's still going to be 2 7s at the end. What do we normally do though? Notice I normally put the power on the outside. I would much rather do that than have 50 to 32 cubed. Oh my God, screw that, get out of there. So in working it out, I normally put it outside. Here I actually normally put it inside just to make it a little more compact.
Oh, okay.
When I don't know what the hell the number is, I might as well just put the damn thing on the inside and say there.
And so what would be the answer now for that one?
That's the answer.
That's the answer?
I can't work it out because I don't know what this equals. I can't solve for x. I'm just rewriting it in another form.
So you can write it in 4 different ways?
Yeah, you can write it in several different ways. This way, or that way.
Okay, that's what I'm trying to understand. Okay.
Okay. Now what do you guys think about this here? X to the 2 7s times x to the 3 14s. So remember that rules never change. The only thing that change are the players. I got a mosquito who's trying to do my math.
Is it square root of 14 x to the 3rd?
Now, you don't want to put it in the radical form here. Because what's the property when I multiply like bases?
Multiplication.
Mosquito.
When I multiply like bases, what are the powers? You add them, right? What's x squared times x to the 7th? X to the 9th, 2 plus 7. Rules never change. I still have to add these. But how do I add fractions? They need
Common denominator.
LCD.
So that would be
Rules never change.
4 14.
No cross multiplication here.
4 14.
You just make them have the same denominator and put them together.
4 14.
Yeah. So it'll be 4 14ths plus 3 14ths is 7 14ths, which is 1/2. Freakiness. Do you understand what I mean when I say rules never change? People think that, one thing they think that they have to do something weird here. No, you just add them. And then secondly, they start doing something like something is 5/19, so they start cross multiplying. How do you add fractions? That can't change. That rule can't change. It needs an LCD. Every single step, you say, what is it that I have to do here? What's the rule that never changes? Here I have to add. Here, how do you add them? Like denominator, bam.
Or we can write it.
Yeah, now if you wanted
Root
to,
2.
square root of x.
Root 2.
Yeah, notice how you never put a 2 out here. It's an understood 2 here, right?
Oh, okay.
Why did we do that? Because square root is the most used root. So math people, we like to save time. If you don't have to write this 18 billion times over your lifetime, that's a good savings of, I don't know how much time, right?
How much frustration?
When we don't write any number, it means 2.
Exactly. Cool, yes.
What if there's like a problem with a negative at the beginning?
You're looking at one specific one?
Say like a negative 9 or like a negative 8, 1/3, whatever.
Okay. So if we had a problem like this here, does it look like that?
Yeah.
Alright,
What's the estimate?
so this is, see, where's that negative? It's outside, isn't it?
Yeah, it's not.
And in this case, it really doesn't matter, but this would be negative. Now, what root of 8 am I taking?
Two,
Two.
two,
Third.
a third of it,
Third root. And of course, the third root of 8 is
two.
2. But see how that negative just comes from the right?
Oh,
Right? Now, technically, if they would have done this, then what am I taking the cube root of now?
okay. You have to put it in the,
Now the negative is inside,
Yeah.
which is fine. What do I multiply 3 times to make negative 8?
Two.
Negative 2. Now notice one thing about roots. I can take odd roots of negative numbers. I cannot take even roots of negative numbers. Why? It has to do with the fact that I can do difference in sum of cubes, but I can't do sum of squares. It's the same kind of idea. What is the square root of 4?
Two.
Because it takes 2 2's to make 4, right?
Right.
What's the square root of negative 4?
Minus
If you think it's negative 2, well, what's negative 2 times negative 2?
4.
Oh, shit. Well, then maybe, no, that's 2 times 2 is 4. No real answer.
No real?
Notice how I'm being very careful. There is an answer, it just isn't real. Imaginary numbers. I hate that word, but it's too bad. It makes it sound like it's just like we're playing around with shit that has nothing to do with anything. But without imaginary numbers, you would not be able to describe the electricity coming to your house. If there's any engineers out there that actually use the letter J. In math, we use the letter I for a complex number. And if any of you guys have not done the imaginary numbers, it's coming up. But engineers use the letter J. So if any of you guys are going to go into engineering, you're going to see the letter J. That's just them trying to be different from math people.
By what? Because it is third.
Because what's the square root of negative 4? There is no answer. There is nothing that takes 2 to make negative. If I have 2 numbers and I multiply them, they can never come out negative.
Then I'm not positive.
Two are the same number? Because they're either both positive, and that's positive. Or negative, and that's positive. Oh, shit. Right?
Because the root is square, but if it is the root is 3.
So you can't take the even root of a negative, but you can take the odd root of a negative. Because 3 negative 2's, negative 2 times negative 2 is 4, times negative 2, oh, the negative comes back in, right? Any odd number of things, 2 negatives cancel, but there's still 1 left. If they have 5, every pair cancels, there's still 1 left. You guys understand that?
Cause see,
Odd roots can handle negatives, even roots can't.
so what you're saying over here with a negative 4 is, you said, what negative number times itself is gonna give you a negative, which is not gonna do that because a negative is gonna give you a positive, right?